Hey everybody, this is Larry. This is day 9 of the October Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. My setup's a little bit different today. Let me know how, how that comes out. We'll see. Okay, let's go. Serialize and deserialize BST for today's problem. So we're trying to serialize it, a binary search tree. Okay. It has to be deserialized to the original tree structure. Okay, let me think about this for a second. I am solving this live, so this is not just an explanation video. It's about me going through my thought process, and I don't have an immediate idea on this, so maybe it could go in a couple directions. So I would say my first impression would be to do a sort of I'm trying to think about whether I can take advantage of the fact that it's a search tree, because I think just the fact that it's binary tree, we could do a thing where you just keep on where to pre-order traversal, and then you just maybe you do O of n space. It'll be 2 times n, where where 2 times n space, which is O of n space, in linear time probably. But can we do better knowing that is search, or like that is a binary search tree? Can we take advantage of the fact that I think maybe, but let's I think in general, a lot of things that I would like to do is get the right answer first, and from that we could kind of make incremental improvements to see if they work, right? So I'm going to do that, and I think that works also in theory. I know that a lot of people nowadays are used to Leetcode and other online judges where they submit it and they already have a lot of test cases for you, right? But let's say let's say for whatever reason you don't have internet and there's no test cases and you're just doing it for yourself. Well, you write maybe like a suboptimal solution, then that is correct, that you could prove is correct, maybe that you could show that is correct. Then you could optimize off that by comparing the answers, or this comparing the answers between the two solutions, right? So those are things that I think probably gets lost a little bit, but does come in play a little bit on interviews, because these are things that you could chat about with respect to code quality and stuff like that. But okay, so yeah. So I think I'll return a string is okay. So I'm gonna, I think I'm gonna do a pre-order traversal, like I said, and then I'm gonna basically have a comma limited or comma delimited list of the elements based on that pre-order traversal. So okay, so let's just say array is equal to, maybe a little better name, traversal maybe is equal to the array list, and then we have a classic depth first search, but let's just call it pre-order with the node. If node is none, we return, but we want to, let's just traversal.append. Since the node values are from 0 to 10 to the -4, we could use a -1 as a center value. I was going to put a string or something, but otherwise, yeah, it should be okay. I actually was also thinking about maybe doing it in another way, which is level ordered, which it's okay. I don't think it matters that much. I think as long as you're consistent, it should be okay. But yeah, let's do left pre-order no dot right. I think that should be good enough. So now we yeah, and then now we just could convert this to a string by return comma dot join traversal, right? And I don't know how this testing works, so maybe this does something, maybe it doesn't. Cause okay, I was hoping that would at least print this out, but maybe we could. Okay, just for debugging, right? So let's just print K and then return K, right? Well, maybe not debugging. In this case, it'll be just visualization of. We didn't actually do the pre-order. Okay. I actually forget that sometimes. But yeah, now that we kick it off, oh, int font. Yeah, that's right. I do use ints. That is true. Yeah. So now you get to see 1, 2, 1, and then -1, -1. So you are going to use 2 times the number of space at most. Because of the -1 values, right? Or maybe 3 times the number of space, because for each node, it can have itself and at most 2 other empty nodes, right? So yeah. So then this part looks good, even if it's a little bit inefficient. And then for Deserialize, we just want to construct a node back from the pre-order, and we can do that by let's call process pause, maybe, I don't know. But let's first convert this from data. Let's split it by the comma, and we map that back to an int. So let's just say traversal is equal to this, and then now we can parse. What do you want to parse? Yeah, maybe this parse is okay. I mean, there are a couple ways to do this. You could keep track of an index, or you could. I think the more Pythonic thing is to use a deck or a queue. So I'm going to do it that way. But note that I think it technically is faster and more efficient if you just keep an index and then you move as you go through the array. But I think this is more Pythonic in that is more collections. Basically more how I want to express it, right? So then let's just return parse. And what does parse do? Right? Parse just takes the first element. So current is equal to traversal dot pop left, and then let's see tree node, right? So then we do tree node. This is current value of current value, right? So then node or current node is equal to tree value. Current node dot left is equal to parse, and current node dot right is equal to parse, and then just return current node. This is mostly done, but not really. I have to take care of the -1 case. If current val is equal to -1, return none. Okay, maybe that's it though. Let's see. Fingers crossed. Looks maybe good. It doesn't really tell me. Let's do a few more though. It's a little bit hard to write the input just because now we have to make sure that it is a binary search tree, right? So you can't just do this, I don't think. But I'm just gonna see if it complains. If it complains, I'm just gonna submit it. Yeah, okay. I'm just gonna submit it because I'm a little bit lazy to do it, at least in this interface, right? Because we could have written test in a different way, and I think that would have been okay. But yeah, let's do. Oh, I think this one's wrong. Oops. Let's do one. So this looks okay. I mean, I'm not at this point. Technically, I would have more confidence if I try one big test case. But like I said, I'm just a little bit lazier because of the given test code format. I think if you were to write tests, you would construct these things from the tree nodes, right? And it'll be more obvious what are you trying to construct. But yeah, that's all I have. So it's linear time, linear space. As I said, each node can lead to at most 2 other leaf nodes, because there'll be, if you have I mean, you could do some math on the leaf nodes and stuff like that. I think it's technically 2 times n, sorry, but it's still going to be linear no matter it's 2 times n or 3 times n as the bound. And in terms of time, well, this is a pre-order, and this is just a construct, recursion with getting one element at a time. So it's going to be linear time for both cases. That's all I have. Let me know what you think. Sorry if this isn't my usual setup, but hit the like button, hit the subscribe button, join my Discord, and I will see y'all tomorrow. Bye bye.